till later. Suppose it's possible to pay money today in order to get $1 next year, or pay some amount of money today in order to get $1 in 2 years, or pay a different amount of money today to get $1 in 3 years. So pi t is the amount of money you pay today to get $1 at time t. That's called a zero, because there's no coupon, you just get something at the end. And so though we'll see next class, we're going to start talking about real markets and what the prices of all those zeros are. So anyway, that pi t is something that is traded in the market, and everybody at every hedge fund and every Wall Street bank knows what pi t is at the beginning of each day. Now, Fisher said, well, don't get too lost thinking about pi t, thinking about pt. Take out inflation. You have to make an expectation about what inflation is, but assuming you're right, you can figure out from these pi t's what pt is, the present value price. How much would you pay today in goods to get an apple at time t? Not $1 at time t, but an apple at time t. So it involves knowing what inflation is and what the price of apples is going to be at time t. So Fisher said, there's a lot of stuff you can do with the pi t's. There's also more important stuff you can do with the pt's, and you should always keep those in mind. Okay, so let's take the simplest case where pi t is a constant interest rate. There's a constant interest rate I. So if you ask, what's $1 worth today in terms of how many dollars you can get next year, it's 1 plus I. What's $1 worth today in 2 years? It's 1 plus I squared. So putting it backwards, $1 in 2 years, the price of it today must be 1 over 1 plus I squared. So $1 in t years, the value today is 1 plus I over t. So this is just a simplification. So we'll see that lots of the jargon of economics assumes that there's this constant interest rate that's determining all these prices. Okay, so the first thing to realize is what Fisher calls the present value price. If there were some asset that paid off money in the future, M1 through MT, you don't have to solve the whole equilibrium to figure out what its price would be if you knew the prices of these zeros, pi 1 through pi t, because to get M2 at time 2 just costs you pi $2 today. So you add up the cost of buying all the cash flows of the asset, that has to be the price of the asset today. And if the prices of the zeros are given just by the interest rate, discounting it, then it's just M1 over 1 plus I, M2 over 1 plus I squared, and MT over 1 plus I to the t. I see there's a typo here. Oh, no, there's no typo. It's 1 plus I to the t. They're all these 1 plus I to the t. Okay, so, and now, if the price weren't that, if the price of this bond were bigger, were, let's say, smaller than this, what would you do? You would buy the bond, and at the same time, you'd sell promises to deliver M1, M2, and MT in the future. If you sold those promises and nobody doubted that you would keep your promise, so this is something, Shakespeare would have been suspicious of, but if you made those promises and no one doubted you'd keep them, you could raise this much money by selling all the promises. So you get this much money, and if the bond costs less than that, you could make all the promises, get all the money, buy the bond, have money left over. Okay, then you'd have to keep all your promises. But the bond itself would be paying you money in the future that you could use to keep all your promises. So it has to be that this is the price of the bond, provided that everybody will allow you to borrow and lend at those rates of interest. Because if it weren't, you would either buy the bond and sell all the promises, or in the other case where the price is higher, you'd sell the bond, okay, get all this money, and then use that money to buy all those promises. Okay, and then you could keep the promise, then you could make the payments of the bond because the promises would come due to you. So in that case, you'd have to believe people who made promises to you. So as long as nobody's doubting the other people keeping their promises, it has to be that by no arbitrage, the price of a bond is just the discounted cash flows. That was Fisher's main principle.